Hi guys, so I'm not here today, but you have a wonderful substitute with you. I am going to be here with you on video. So what I'm going to do is actually walk you through a lesson today. You're going to have time to practice, and then you're going to have some work to do afterwards. While I'm writing on the board, I would like you to be taking notes because these are your notes for the topic. So as if I were here, you're going to take notes on what we do up here, what I say, and keep all that in your notebook. This video is posted to my YouTube channel, so if you need to look at it again tonight, or if one of your friends was absent, then just let them know that that is on the YouTube channel. So at this point, I would ask the substitute just pause the video for a minute, give everyone a chance to get out their notebooks and get ready to begin. So our topic today is to take a function table where we have our x and our y, our input and our output, and be able to come up with the rule that generated that table. That way you can apply that rule no matter what your input is in order to find your output. This might be a messy process. You might not find the answer right away, but it takes time and practice. Now, the key is if you come up with a rule that works for, say, the first one or the second one, you want to go ahead and make sure and test it out that it works for all of them. Once you get about 4 that work, you should be pretty confident that the rule is correct. So we're going to start here with number 1. Again, you're going to want this in your notebook. If at any point you feel like you need to slow down, just ask the substitute politely to pause the video. Okay? So here we have our input and our output. I want you to just take a minute and look at this and see if you can come up with a rule. Your rule should include an x and a y and an equal sign. Okay? Something is being done to x to equal y. Okay, so if you're done pausing the video, we should be ready to begin going over this one. Okay, so what could we do to x in order to get to our y? Well, we could add 2, but that doesn't work here. So we're going to have to do more than that. If you notice the change in here, we are increasing by 1 each time. Each time we increase by 1, I'm leaving 5 off because that's not the same increase. We increase by 2 here. Okay? So we're actually going to be using a multiple of 2, or a ratio of 2 over 1. You might have remembered that from last year. So a ratio of 2 over 1, we're going to do 2 times our input, right? Because we're increasing at that rate. Then we have to do something else perhaps to get to that y, because 2 times 1 is 2. That's not 3. So if we then would need to add 1. Okay, let's test it out for that one. That would be 2 times 1 plus 1 is 3. Okay, that one works. Let's try the second one. 2 times 2 is 4, plus 1 is 5. That works. Okay? Go ahead and take just a few seconds and try to see if it works for the last 2. You can pause the video for about 3 minutes here. Okay, so if you went and applied that, you should be able to see that 2 times 3 plus 1, that would be 6 plus 1 is 7. That works. And 2 times 5 is 10, added to 1, and you do get 11. So our rule, remember, must have an x, must have a y, and the equal sign, is 2 times our x, added to 1, gives us our output. And that would be your answer. All of this is your work. This is your answer. Okay? That can also be written as y is equal to 2x plus 1. Your property of equality allows you to flip-flop on either side of the equal sign. All right, take a minute, pause the video here so that you can go ahead and copy this chart down. Okay, so let's get ready to begin with this one. We have our input, we have our output, we have our rule. See if you can come up with the rule on your own. Just take 1 minute to do that. Okay, if you're stuck, something to look at is the change that's happening in your x compared to your y, or your input compared to your output. So here again, we're increasing by 1. Here's the increase of 2. On this side, every time we increase by 1, we increase by 3. But when we increase by 2, we actually increase by 6. So if you think of this back to ratios, your 3 to 1 is equal to your 6 to 2. Every time you changed 1, you changed 3. Every time you changed 2, you changed 6. But they simplify to be the same ratio. So we actually could say that our x is increasing at a rate of 3. So we know that we would have a 3 times our input. So now 3 times negative 1 would be negative 3. To get to negative 5, we'd have to go 2 further left, or take away 2. So the rule we're going to test out here is 3x minus 2 equals y. Okay, let's use the values that we have. 3 times negative 1 is negative 3. Take away 2, we get negative 5. Remember, you're taking notes on this. This is your studying for this skill. 3 times 0 is 0. Take away 2, we get negative 2, so that matches. 3 times 1, remember a number right next to a parenthesis is multiplication, if you don't remember that. 3 times 1 is 3, take away 2 and we get 1, and that works. And then we have 3 times 3 is 9, take away 2, and we get 7. And you could always test this out with any input. You could put in a decimal for an input, a fraction. You can go up to 1,000,000 as an input. When you put that input into the rule, it will give you your output. Okay, so now that you've gotten some notes and some practice in pairs, you're going to complete the function rules pair check worksheet. Substitute has that and we'll pass that out. That should be sitting on my desk, so make sure you pass one out to everybody. One person in the pair will answer the left column, and one person in the pair will answer the right column. Then you are to check each other's work. After you've checked each other's work, you're going to answer them together. So in the end, each person should have all the answers for the left and all the answers for the right column. You will have about 10 minutes to do this. I would like you to pause the video here so the papers can be passed out, and to start about 10 minutes. When everyone is finished, or the 10 minutes is pretty much up, go ahead and start the video back up for our next piece. Do your best, work hard, and make sure to stay on task. Okay, for your answers on the back of that worksheet, they are all up here. Your input-output table is the first one. If you notice, you're increasing by 1 along your input, 4 along your output. Your rule is y equals 4x, and your missing values were 20 and 40. The second one, you are increasing by 2 each time. That's where you get this rate of 2, or an increase by 2. But when you substitute that first input in, you need to go another 3 to get your output. So your equation is y equals 2x plus 3. The third one is a little bit tricky. It's kind of just, can you figure out the pattern? And your pattern here is that your rule is y equals x to the third power. That one was a tricky one. You won't see one like that often. Just wanted to throw that in there. And your last one, your input is increasing by 1 as your output increases by 3. So we have a rate of 3. And the difference as we do 1 times 3 to get to 4 is to add 1. And that rule is consistent all the way through. Our missing values were 16 and 61. At the bottom of this page, the Kessler twins developed an experiment where each time an ant climbed up 2 inches, he fell back 1/4 of an inch. Fill in the table to represent the progress of the ant in a hole. After 1 attempt, he'd be at 1 75/100 inches. After 2, 3 5/10 inches. After 3, 5 25/100 inches. After 4th attempt, 7 inches. And 5th attempt, 8 75/100 inches. Which of the following rules represents the progress of the ant if P is the position after each fall and A is the number of 2-inch attempts at climbing up? C is your correct answer. P equals 1 75/100 A, or the position equals 1 75/100 times the number of attempts. And the last part, if the ant makes 7 attempts at climbing up, what will be his position after the last fall? That would be 12 25/100 inches. If the ant must climb out of a 14-inch hole, about how many attempts will it take him to climb up? about 8 attempts. Okay? Okay. At this time, I'd like the substitute to please pass out the growing dots activity. If there's still time in the period, go ahead and work on that now, students. If there is not time, please take this home and complete it for your homework. This needs to be placed into the bin either by the end of the period today or tomorrow. When I come back, I'm going to be looking for that activity in the bin. This will be your graded activity from today, the growing dots activity. Make sure you are thorough in your responses and you give good explanations. It is your responsibility to either finish it in class or finish it for homework. I'll see you guys soon. Thank you for being great and have a wonderful day.